Centrifugal pumps. Centrifugal pumps are a common type of industrial equipment. Centrifugal pumps perform a valuable function. They provide the energy to move liquids from one place to another. For example, centrifugal pumps can be used to pump cooling liquids to plant equipment. They can be used to pump water and other liquid for plant processes. Because centrifugal pumps perform so many necessary functions, it's important to keep them in good operating condition. And when a problem develops, it's important to fix the problem and get the pump back into full service as quickly as possible. That's where you come into the picture. As a troubleshooter, you're expected to figure out what the problem is and how to fix it. You're supposed to do this with a minimum of downtime. And the fix is supposed to last a long time. Now that's a pretty tall order, but you already have two important pieces of knowledge that will help you to be an effective troubleshooter. You already know how centrifugal pumps function, and you're familiar with the basic steps to troubleshooting. The purpose of this program is to join these two pieces of knowledge to help you successfully troubleshoot some common centrifugal pump problems. We'll be troubleshooting several specific problems, but you can apply what you learn to other problems you may have to troubleshoot. In this program, we'll show you how to troubleshoot overheated bearings on a centrifugal pump. We'll talk about some of the symptoms to look for, and we'll see how these symptoms can help you determine what caused the overheating. Another problem that we'll be troubleshooting is excessive gland leakage. You'll see how packing glands normally function, and you'll see how to figure out what might have gone wrong to cause excessive leakage. We'll also talk about how to troubleshoot a loss of capacity and loss of head. This procedure will teach you how to pinpoint symptoms and causes in what may at first seem like a vague problem concerning pump function. As you can see, we'll be talking about some big topics. Much of the information you learn in this program can be applied to troubleshooting a variety of common centrifugal pump problems. For the purposes of this program, we'll be working on a particular centrifugal pump, but of course the information you learn will be applicable to other centrifugal pumps. Throughout the program, we'll focus on the thinking process that makes for successful troubleshooting. As you know, one key to successful troubleshooting is to compare the conditions necessary for normal operation to the conditions at the time of the problem. To help you keep track of all the details, we'll use a chart that a good troubleshooter might use to organize his thinking. For the purposes of this program, we'll call this chart a decision-making diagram. Our decision-making diagram presents the different elements of the troubleshooting problem. For example, the top block in our diagram represents a problem condition for a centrifugal pump. The second row of blocks identifies the major conditions we would expect to find if the pump were functioning properly, and the following row identifies possible causes of the problem. Throughout this program, you'll see a troubleshooter working his way through the information represented by our decision-making diagram. For example, you know that there are a number of sources of information about the symptoms of a problem. These sources include talking with the operator, and you can check facility records. The sources for information about normal pump operation include your own knowledge of pump components and function. And of course, excellent sources for this type of information are the manufacturer's manuals. Where you as the troubleshooter fit into this procedure has to do with logically working your way through all this information. You'll need to compare what you know about the problem to what you know about the conditions necessary for normal operation in order to determine the cause of the problem. In this program, we'll be discussing a number of possible causes for the types of pump problems you'll probably encounter. In your facility, you may find other causes for such problems. But what we discuss here may be applied to all centrifugal pump troubleshooting regardless of the cause of the reported problem. Tasks performed in this program follow the manufacturer's instructions and include what we have found to be good work practices and safety procedures. We've slowed down the work pace in some instances so that you can follow the steps more easily. Your facility may require work practices and safety procedures that differ somewhat. It's important that you always follow your facility procedures. Well, I think we're about ready to take a look at one pump problem you might run into. We'll get started in the next segment. Remember, troubleshooting centrifugal pumps requires that you make use of two important pieces of information. To be a successful troubleshooter, you must use both your knowledge about how centrifugal pumps function and your knowledge of the troubleshooting procedure. You'll find a reminder of the basic troubleshooting procedure steps in your workbook. So stop now and read the material in your workbook. Well, now that you know what this program is about, let's talk about one problem you may come across. An operator has noticed some problems developing with a centrifugal pump that he's just started up after a couple of days out of service. After being notified by the operator, his supervisor has asked our troubleshooter, Gene, to see if he can determine the nature of the problem. The first thing Gene needs to do is find out as much as he can about the problem. He can do this by talking with the operator, performing a check of pump operation, and having a look at facility records. Let's see what information he finds out. First, he talks with the operator. The operator says that the temperature on the outboard pump bearing is up a little, not enough to cause him to shut down the pump, but enough to indicate a potential problem. The operator has been monitoring the temperature, but so far there's been no indication that it's still going up. The operator first noticed the temperature increase when he made his last rounds, about 30 minutes ago. Even though the information may not seem particularly complicated, you may find that it's a good idea to jot down notes while you're investigating the problem. Be thorough in your questioning. For example, Gene asks if the operator noticed any other symptoms or indications that the pump isn't functioning properly. The operator says he thinks there might be some excessive noise and vibration in the bearing. It's important to find out about normal operation and to use your own knowledge to help you formulate your question. For instance, Gene knows that the bearings on a centrifugal pump support a rotating shaft. The shaft must be properly aligned in order for the bearings to perform without problems. Of course, a correctly aligned shaft will maintain all components, such as the impeller, wearing rings, and bearings in their proper relationship. On the other hand, misalignment can cause component problems, such as causing the bearings to overheat. But if misalignment caused the outboard bearing to overheat, it would probably also cause the inboard bearing to overheat. Therefore, Gene asks the operator if he's noticed an increase in temperature, noise, or vibration on the other bearing. The answer is no. Let's take a look at a decision-making diagram for this problem so far. The subject is the overheated bearing, and one condition that's necessary for proper bearing operation is proper alignment. During your conversation with the operator, be sure to note everything that could possibly help you solve the problem. For example, Gene learned that the bearings had been greased while the pump was out of service. Gene considers this to be an important piece of information because he knows that bearings must be properly lubricated in order to function. As you know, lubrication reduces friction between moving surfaces. Proper lubrication also helps prevent overheating and wear. Once you finish questioning the operator, you need to check other sources of information. As a troubleshooter, whenever possible, perform an operational check of the pump so you'll know firsthand exactly what the symptoms are. You may find clues about the cause of many problems in the indications on the gauges and recorders. Our gauges indicate that discharge pressure and running current are normal. For this particular problem, check the area around the bearings for evidence of lubricant having been forced past the seals. Overgreasing could result in overheating. The area on this pump looks properly clean. Check the temperature on the bearing. Follow your facility procedures for making this type of check. In our case, Gene uses a pyrometer to get an accurate temperature reading. The temperature has increased slightly since the operator last took a reading, but it's still within the acceptable range and doesn't warrant shutting down the pump. If the temperature did exceed operating limits specified by the manufacturer or facility, you'd have to shut the pump down to protect it from damage. Of course, it's helpful to be able to observe the equipment in operation, but it's not always possible since operating equipment, when it's malfunctioning, could damage the equipment. Gene goes on to check the temperature reading on the other pump bearing and on the two motor bearings. You'll remember that the operator told him there was no temperature increase on the other bearings, but it's good practice to check both bearings. After finding the temperature at the other pump and motor bearings to be normal, Gene makes a check for excessive vibrations at the outboard bearing. Excessive vibrations could indicate bearing failure. When the probe is placed on top of the housing, it measures vertical vibrations. Each time he takes a reading, he records the reading. Later, he'll check these readings against the specified normal range for this pump. When the probe is placed on the side of the housing, it measures horizontal vibrations. Make sure you place the probe as close to perpendicular to the housing as possible. Again, he'll check these readings against the normal range for this pump. Be sure to hold the probe steady long enough to get an accurate reading. When the probe is placed on the end of the shaft or bearing housing, the meter measures axial vibrations. Any excessive vibrations readings on this pump could indicate misalignment, so all three of the vibration readings will have to be checked against manufacturer specifications. If vibration is found to be excessive, a detailed vibration analysis may have to be performed. Even though the operator didn't think there was an increase in vibration at the inboard bearing, Gene goes on to make a check there also. He will check these readings against the normal range for this pump. Well, that completes the symptoms verification procedure for this problem. So far, Gene has been finding out about the problem. He's done this by questioning the operator and by performing an operational check of the pump. He's also been thinking about information about normal operation of the pump. He needs to know as much as he can about the pump. Then he'll be able to compare normal operation to what's actually happening in order to figure out what's causing the problem. One place to find information about normal operation is in the manufacturer's instructions. Gene takes a look at the manufacturer's instructions for this pump to see what information there is on the bearings. And he checks the readings he took during the operational checks against those in the manufacturer's manual. Sometimes the manufacturer includes troubleshooting information in the manual. This manufacturer identifies the two conditions necessary for proper bearing operation that Gene has already considered: proper alignment and proper lubrication. You can also find information about normal operation and pump problems by looking in the facility records. We'll watch Gene do this in the next segment and see what he finds out. But first, let's review. It's important to find out as much as you can about the problem. Question the operator thoroughly. Think about what you know about normal pump operation in order to form your questions. Symptoms for overheated bearings may include too high a temperature at the bearing or abnormal vibration and noise. Be sure to check the temperature and vibration at both inboard and outboard bearings. Two common causes of overheated bearings are alignment problems and lubrication problems. Find out as much as you can about normal operation. Then you'll be able to compare normal operation to what's actually happening in order to figure out what's causing the problem. Stop now and read the material in your workbook. In the last segment, we watched the troubleshooter question the operator, perform an operational check, and check the manufacturer's instructions. He's been looking for as much information as possible about the problem and about normal operation. Another source of information is plant records. You can find information that might give you a clue about the cause of the problem by looking at the operating logs and the maintenance logs. So Gene takes a look at the logs first. The logs note that the bearings were recently greased while the pump was out of service. They also note when the pump was started up again. The logs indicate who greased the bearings, so Gene makes a mental note to talk with him. The maintenance logs show the recent greasing of the bearings and mention the type of grease required. No other work has been performed for many months on this pump. Gene decides to talk with the operator who greased the bearings. He wants to make sure that the proper type of grease was used. The operator checks and verifies that the specified type was used. Gene also asks if the operator noticed any indications that the old grease was contaminated. If the old grease was contaminated, there may be some condition in the pump that could also contaminate the new grease. But the operator says he noted no signs of contamination. These are important pieces of information. Gene knows that using the wrong type of lubricant can cause overheating. And he also knows that contamination of the lubricant can cause overheating. Even though the bearings have been recently greased with the proper type of grease and there's no sign of contamination, the lubrication system could still be the cause of the problem. As a troubleshooter, be thorough as you investigate possible lubrication problems. For example, in addition to the wrong type of lubricant or contaminated lubricant, overheating can also be caused by excess lubricant or too little lubricant. At this point in the troubleshooting process, you should be working toward forming a theory about the cause of the problem. You know that bearing problems are usually caused by misalignment or problems in the lubrication system. Do you think the problem was caused by misalignment or by lubrication problems? You've already seen our troubleshooter perform some simple vibration tests, and we've discussed some possible causes of lubrication problems. Think about the question. You can help answer it by putting together all the clues given so far. Well, did you come up with an answer? Do you think the overheated bearing is caused by misalignment or by lubrication system problems? Let's see whether your answer is the same as the one Gene has come up with. Gene thinks the problem must be caused by the lubrication system because several pieces of information point away from the misalignment. For example, there was no excessive vibration on the bearing housing. Excessive vibration may indicate misalignment. Only one bearing seems to be affected by the problem. Misalignment would affect both bearings, and pump function has not been affected as yet. So for the moment anyway, misalignment can be ruled out. On the other hand, even though the bearing was recently greased with the proper type of grease and there weren't any signs of contamination, it's still possible that the overheating was caused by excessive grease or by too little grease. So now Gene will investigate the lubrication system to see if his theory is right. It's important to verify as much as possible that your theory is correct. You don't want to make any changes unless you're sure your theory is correct. After obtaining facility approval, he'll check to see if the bearing has the right amount of lubricant and whether or not the lubricant is in good condition. It's difficult to tell if you have too little grease, but you can look for excessive grease. If the reservoir on the bearing has a drain plug, one way to check for excess lubrication is to remove the plug while the equipment is in operation. Watch for excess grease to ooze out of the port. In this case, however, no grease oozed out of the port, so the problem was not excessive grease. If excess grease does ooze out, then you could replace the plug after all the excess grease has drained out. You would have to let the pump run for a while. It could take a while before the temperature would decrease, so you would have to monitor the temperature until it returned to normal. You should also check the condition of the grease to see if contamination is the cause of the overheating. You can do this by first rubbing a smear of grease onto a lint-free towel. Look carefully at the smear. Can you see any signs of contamination? Do you see any pieces of metal? Pieces of metal might indicate that the bearing may have been damaged and could fail. If you don't see any pieces of metal, rub some of the grease from the smear between your finger and thumb. Can you feel anything gritty that might indicate contamination? Gene didn't see any bits of metal or feel any dirt. He thinks that contamination is not the cause of the problem. He has checked for excessive grease, and earlier he checked to see whether the seal was leaking, but the problem could still be too little grease. To verify that there is too little grease, you can add grease in accordance with your facility procedures. Then, monitor the temperature to see if the temperature comes down. A temperature decrease would indicate that there probably had been too little grease on the bearing. So in this case, verifying the cause of the problem and fixing both the problem and the cause are the same thing. The last part of the troubleshooting process is to take steps to prevent the problem from happening again in the future. On certain pumps, some plants may require that you shut down the pump and disassemble, clean, and inspect the bearing. This is because even though there hasn't been any indication of bearing damage, the life of the bearing may have been decreased. If you clean and inspect the bearing, you may be able to prevent future problems that could result from a worn bearing. Whether you have to inspect the bearing or not, think about ways to prevent lubrication problems. For example, you may want to talk with your supervisor about additional procedures or additional training. Well, that completes this troubleshooting procedure. In the next segment, we'll start troubleshooting another centrifugal pump problem. But first, let's review. Normal operation requires proper alignment. Indications that alignment is proper include a lack of excessive vibration, only one bearing being affected, and a lack of effect on pump function. Normal bearing operation also requires proper lubrication. To prevent bearing problems, the proper type of lubricant must be used. The lubricant must be free from contamination, and there must not be either excessive or too little lubricant. It's important to verify that the lubrication system is the cause by checking for excessive lubricant, contaminated lubricant, and too little lubricant, and by checking to see if the proper type of lubricant was used. Be sure to follow your facility procedures to know how to properly fix the problem. You may be required to disassemble a bearing, clean it, and inspect for damage. Stop now and read the material in your workbook. In the last segment, we watched the troubleshooter determine the cause of an overheated bearing. In this segment, we're going to deal with another common centrifugal pump problem, excessive gland leakage. Of course, the first thing you should do is find out about the problem. One thing you'd have to consider is a packing problem. I'm sure you know that packing is a series of rings placed around the shaft. A lantern ring distributes the sealing liquid to the packing and the shaft. It is important that the lantern ring and the packing rings be properly installed to prevent excess leakage. The rings are compressed by the gland follower to form a seal. I'd like you to stop the program now and spend a few minutes thinking about what questions you would ask if you were the troubleshooter. Did you figure out some questions? If your questions fit in the following categories, then they'll probably be helpful. What were the symptoms that caused the operator to report a problem? When did the operator first notice the problem developing? Where did the problem occur? Has the operator made any changes in an attempt to correct the problem? When was the last time maintenance was performed on the packing? Further checks in maintenance logs may provide additional information. Well, Gene asked the same types of questions. The operator told him there was too much runoff. The runoff came from around the gland follower. The excess leakage appeared only at the outboard packing, not at the inboard packing. The operator first noticed an increase in leakage 2 or 3 shifts ago. The leakage has steadily increased since then. The operator tried tightening down the packing gland, but that didn't seem to make much difference. And at that point, he reported the problem. The answer to the last question Gene asked was that the packing had been changed not long ago. Gene is going to go right to work with his operational check. The runoff on the outboard packing seems quite heavy, just as the operator has indicated. Although the fluid in this pump is water, other pump fluids may require special safety precautions. Be sure to follow your facility safety precautions when checking runoff. Check for the source of the excess leakage. Water flowing from the inside of the sleeve might indicate a problem with the sleeve. That's not the case this time. Also, check the gland follower. If the packing is fully compressed, the pump should be repacked, but ours is not. So then he walks around to the other end of the pump to verify that the inboard packing is not leaking excessively. If the packing was leaking excessively on both ends of the pump, then it might indicate that there's been a change in the condition of the sealing water that has damaged the packing. On this pump, both ends would be equally affected by a change in sealing water, since both packing glands receive sealing water from the same source. So even though the operator said he hadn't noticed any problem on the inboard packing, it's important to verify that information. Gene finds that the runoff from the inboard packing looks normal. As Gene studies the problem, he reviews what he already knows about the conditions necessary for normal operation. At this stage, a decision-making diagram of this troubleshooting problem would look like this. Gene will concentrate his thoughts on sealing liquid supply, gland adjustment, and the condition of the packing. To find a probable cause, Gene will concentrate on investigating these 3 areas. First, he'll go through plant records. He takes a look at the operating log. It shows notations of when excessive gland leakage started. There is no other mention of the problem. The maintenance log, however, contains some information that sheds quite a bit of light on the problem.